Let us welcome our speaker tonight, John Council. And let me let you know he's in Atlanta right now, by the way, working on another project. So he's saying staying up. I was saying staying up nice and late for us because we've been doing a lot of all night stuff. So I guess in some respects it's an early night for him. But John has a very varied resume. He's been over in Catalina an awful lot, as he mentioned. He runs the history of. I never get the name exactly right.
History exhibit.
Yeah, I always call it the diving history, the Avalon history of diving, but the museum over there, which ties in great because he's also the president of the Historical Diving Society for USA. So there's a lot of good stuff there. But he's one of these people that knows everybody and talks to everybody in the industry, and he's done an awful lot of stuff, including a lot of work with NASA. As you know, if you remember, we had Bob Sanders on in December, who's the medical director at the NASA Neutral Buoyancy Lab. So as you know, NASA uses water a lot of times underwater as a way of training the astronauts. And John was involved in a lot of these things. And that's actually sort of going to be what the focus is tonight. So without further ado, let me have you all give a Zoom seekers welcome. Because they're all muted, we just happen to do that kind of a clap, John. To Mr. John Council, and John, take it away, and hopefully I'll be your technical director and won't mess this up. Oh, and by the way, COVID cannot be transmitted through Zoom, so you're all safe.
We're safe. Ken, thank you very, very much, and thank you to Reef Seekers for inviting me to be your guest speaker this evening. It's a pleasure and an honor to address everyone in your group. Just a little bit of background. A lot of people know me from the Catalina area, but I actually grew up in Seattle, Washington, and 2 weeks of high school, I was up in Alaska on one of my first real jobs in my life on a Alaska king crab fishing boat. And one of our crewmen, our chief engineer on the vessel, was an ex-Navy diver instructor, and he had a dive, rig on board to do repair work on the ship, and he was the only qualified diver on deck, and so he was going to act as the basically the dive supervisor for the vessel. And so he needed 2 guinea pigs to learn how to dive, actually heavy gear, Mark V, helmet and hard dress, and so his nephew Mitch Cook and I were selected, and we became the 2 guinea pigs to learn how to operate this gear under the tutelage of Sonny Preston. And I still remember to this day, as he was closing the gate on the Mark V helmet, he said, my last instructions were to, if I run into any shit, just yank hard 3 times on the line and it'll haul my sorry ass topside. And another thing, don't piss in the suit. Those were my big instructions. So that's where the diving started for me. And for the next decade or so, it was really just sport recreational diving with my friends and brothers. And, our reasons for getting in the water were to go grab lingcod and some Dungeness crab and some scallops. And that was really our focus. Little did I know that my schooling and education, studying for marine bio background and behavioral sciences, that I would eventually find my way back up to the Arctic, but this time as a scientific research diver, collecting data for the EPA and NOAA. And through those projects, I was trained as a submersible pilot up in Canada through Phil Newton's operation up in Vancouver, and trained as a sub pilot. And when I, became proficient at operating submersibles, it's sort of like the floodgates blew open for me. And next thing you knew, I was working on all kinds of projects all over the world, piloting submersibles. And one of those projects that I was fortunate enough to be involved with was down in Key Largo, Florida. And I got to work with astronaut Scott Carpenter and Navy aquanaut Bob Barth and Dr. Sylvia Earle and Jan Koblik. And I mean, really a who's who listing of everybody in sort of the scientific or commercial diving world as a submersible pilot, because we were putting on a program down there called the Scott Carpenter Man in the Sea program, or the MITS program. And that MITS program was involved with training Navy personnel and also NASA astronauts. And we had a lot of different things going on simultaneously. Part of that program involved them basically mirroring some of the Sea Lab mission work that Scott and Bob Barth had been involved with, and where during the Navy Sea Lab programs they were living at depth for extended periods of time, using saturation diving technologies and things like that, but also living at extreme depths, in some cases in excess of 600 feet for weeks at a stretch. So we weren't pushing the limits that hard for these people, but what we were doing is keeping them underwater for 11 days in underwater habitats, and then using peri-hurricane Bellsat systems to, get to and from the depth site. That wasn't really deep; it was only like 30 feet. However, they were saturated after 24 hours, of course, and but we had submersible operations, which I was in charge of, and we had a nautical archaeology program set up there so for them to basically work on nautical archaeology projects. We had marine bio studies, so somebody would be doing a plankton tow, and the crux of all of this stuff was to take like groups of astronauts and then stress load them and give them 50 objectives to try to accomplish today, and then they'd have a team leader that would basically delegate to their group of maybe as many as 5 different individuals living in this habitat, and one person be responsible for doing plankton tows and IDing creatures. Oh, I got the cops are after me here.
Oh,
anyway, and with the submersible, it was kind of fun because we used the sub as a lifting system to carry a large section of pipe across the lagoon and hold it in a buoyant station, and then other aquanauts could build a flange and bolt it together while the sub held this large pipe in on station using thrusters and the buoyancy of the sub and everything. And then once they got finally, all pieced together, the sub could release the weight or the load from underneath the sub, and then the pilot had to respond by adjusting the buoyancy and the ballast of the sub so it didn't just rocket to the surface once it lost that load. And so a lot of task loading going on simultaneously, and then the next day you'd add some more things to the list, the next day some more things and some more things, and by about day 5 you'd have these guys where they were falling well behind on their list of objectives. And that was really sort of the secret thing that NASA was really interested in, was finding out how these people worked under real stressful conditions where they had a lot of tasks to try to accomplish, and how well they would deal with that. And it was kind of funny because by day 5 you'd have guys responding like, Houston, we've got a problem. Well, what is it? And it's like, well, hey, if Bob says okey doke one more time, I think I'm going to kill him. And it's those kinds of things where people start to react differently under those stress loading conditions. And that's really what they were trying to establish. Well, that became sort of the foundation for what became NASA's NEEMO program, which is NASA's Extreme Environment Missions Operations, which mirrors those same principles. You task load these individuals with lots and lots of things to do, and you keep adding to that list, and it mimics a weightless environment where you're using a life support system to keep you alive, but you've also got a job to do, and that job could be any number of different things, and you just keep throwing stuff at them. And after a period of time, they start to get a little bit worn out, tired, stressed, and then you can see where their performance is. And a lot of these missions today, it's been 20 years now that they've been running these programs. Most of them have been run in Florida at the Aquarius underwater habitat, the laboratory there. And then they also run some at the Neutral Buoyancy Lab in Houston at the Johnson Space Center, where they've got the full mock-up of the International Space Station on site. And they can actually work and lock out, and they dress out in their suits. And many of these pieces of apparatus that they're using are, they're essentially dive equipment, really. And the parallels are so similar in how they operate using that equipment and what they would use on actual missions in space, that the crossover is pretty realistic. And so they get the advantage of feeling that neutral buoyancy or that weightless effect. They get a bunch of things they have to do, and then the data that NASA is able to glean from these missions is they see where their personnel need additional training. They find out where those people have maybe strengths in certain areas, and maybe in some other areas their strengths need to be maybe recipients of additional training, things like that. But overall, it's just a great kind of end result product for NASA to learn on a lot about their personnel, a lot about other personnel from other space agencies around the world, because they do a lot of collaborative work with the European Space Agency, Japanese space agencies. And so they do a lot of cross training, and it's a spectacular program. I mean, it's something that's fantastic to watch and to see how people respond, and the testing of new equipment is really dynamic. We ended up in 2019, Bill Todd, the head of the NEEMO project, as well as his coworker Mark Regan, they sort of conceptualized this back 20 years ago, and started doing these projects and bringing in different apparatus and what have you. They have developed a really strong program for NASA, and it's well received in the upper echelons of the agency. They like what the results of what they're getting information wise, the data that's being gleaned from the missions, and they keep adding and creating new things to be tested. And one of the things they wanted to do was break away from some of the missions that have been done in the neutral buoyancy lab and over in Florida at the Aquarius habitat. The mission in 2019, the real focus was on geologic study. And the reason for that is there's a lot of things that can be understood if you travel to Mars, for instance, and you start encountering different types of geologic structure. If you really have a strong understanding of what forces create those geologic anomalies on a planet. If you run into sedimentary rock, for instance, there's only certain conditions where sedimentary rock can exist. It's because it was at one point either volcanic ash or dust or something that settled out on a liquid. It wouldn't necessarily have to be water, but it could be water or liquid methane or liquid nitrogen or something, depending on the temperature of the planet. But that liquid would have this particulate in suspension, and it would gradually settle down over millennia, and then eventually you would have layers of stone. And then if that stone was turned upright or turned vertical, then that would indicate that you had volcanic action, most likely, or some kind of large impact with an asteroid or something that pushed those stones. There's all these different things that would create different types of geologic structure. And so when they understand that, if they travel to Mars, they can look at these things and they can say, we've just encountered, a pyroclastic ejecta material, which means that there was some kind of either high velocity strike or there was volcanic activity. And so those are all indicators of different types of geology. And so that's a great way for them to learn. Another thing that I thought was pretty fascinating is they were testing out a brainwave monitor. And so these astronauts would wear this device. It almost looked like a little headband, and it was monitoring their brainwaves, and they could start task loading these individuals. And you could see whether or not their performance was starting to taper off if they became too task loaded with too many things to try to process at once. And in that situation, you could take that data and you could see where their performance level was tapering off. And if you encountered those same kind of conditions later on, like say somebody's working on a bunch of different things on their trip to Mars, and then you can see their performance bands start to taper off, you say, okay, let's not give them any more things to do right now and let them get back to where their performance is peaking out and they're getting the most bang for their buck. So that was kind of impressive. And then another technology that was being used were Loomis glasses for the submersible pilots and the exosuit pilots. And they would be able to pipe in any kind of data or streaming video or anything like that that you would normally have on a laptop computer or home computer, they were able to project that onto the lenses of these glasses. And so you could pipe down maps and charts and objective lists and all kinds of things you could put on there, and you could still see through the glasses. So you could see what was out ahead of you, but you could change your focus and read what was on the lens of the glasses. And you could read out, like, okay, well, we want exosuits and deep worker to rally at 1200 hours at checkpoint Bravo, for instance, and they could see a chart in real time, almost like a GPS. They could see where their location was in relation to checkpoint Bravo, and then they could start maneuvering their submersible craft to that point, and they would see where their timeline was on the screen and see that they've only got 15 minutes left to try to get there. And so once they rallied up at checkpoint Bravo, then we give them a new objective, and maybe it would be for the exosuit to latch on or step up onto the back of the deep worker submersible, and then it would sort of piggyback ride and come on home. So there's a whole host of things that were able to be done that way, but the glasses were a really fantastic piece of equipment to be able to use. And I got to say that we set up, we wanted to do these works at Catalina Island, particularly because all the geologic structure that was here. There's, down in Florida, they basically have karst limestone, ancient coral reef. That's the only thing they really got going, and they don't really have too much else over in Houston either. So Catalina was something that was really attractive because there was so much different geology on the island. You've got plate tectonic action, you've got lava flow, you've got sedimentary stone, you've got all these different things, and in the short kind of range of geologic distance, you've got a lot of different things going on. And so it was an ideal location. Generally speaking, the waters are relatively clear here on the island, not all the time, of course, but generally. And it was close to Los Angeles, so that we could get equipment here readily. It wasn't like it was some out of the way location that you couldn't get equipment to the island. And then we decided to not operate anywhere near Avalon because we didn't want a lot of looky-loos. But down at the USC Wrigley Institute down at Two Harbors, that became the sort of the target for us. We kind of looked at places to operate, and those folks down there couldn't be better. It was just fantastic place to operate. They hosted us. They provided us a place to create a mission control center. NASA personnel went in there with their big screen monitors and computers and miles of cables and satellite feeds to tie into Houston Space Center, and we're piping a lot of footage live time to there. And I mean, these guys just made it look like it was easy work, and obviously it's not, but a pretty spectacular operation that they put together there, and it was just a lot of fun. When we did the work out here, the work with the deep worker submersibles and the exosuits, they were important because they create a challenge for the astronauts to have to learn how to operate these craft. And it's not unlike working in space with some of their EVA, which is their extravehicular activities, spacewalks and things like that, or moonwalks, or maybe Mars excursions. Basically, you have to be able to work in these environments using equipment that can keep you alive, because these are obviously environments that are not conducive to sustaining human life. And so for that to occur, you've got to be able to utilize some form of equipment that keeps you alive. And the focus is really not on the apparatus, the subs, or the life support equipment. Those become the mechanism to get you to the job site. And so while you have to learn and become proficient in how to use this equipment, it's really not a lot unlike getting in your car and driving to the office in the morning. It's not, the focus isn't really the vehicle. The vehicle becomes the mechanism to get you to the job site. And so that's how we sort of view the subs and the exosuits and things like that, is these are the mechanisms that keep you alive, and these are the things that get you to where the objective for the job is. And so while it's important to know how to operate them, that sort of becomes secondary to the task at hand. And the task at hand in this situation would be to go, get geologic samples, go take photographs, test equipment, that type of thing. And then these are the means by which you can go accomplish those objectives. And so that's how it kind of worked. But we did a lot of great stuff, and the mission was a huge success on Catalina Island, and we were actually slated to run a 5-year program here. I hope that once all the COVID stuff settles down, that we can resume and get back to operating here on the island, because I think it's great for Catalina. I think it's great for the Wrigley Institute, the USC Wrigley Institute out there. They do okay with it too, and it's certainly good for our astronauts in their training, because they become more proficient at what they're trying to do, and they get some real world stuff. A lot of people oftentimes ask about, why the training in the water and that kind of thing. Well, it's one of the best ways to stimulate weightlessness, of course, but it also adds a different element or a different feature, which is that you actually have a real inherent risk in doing it. And the difference in working in water to do some of these tasks versus getting on a flight simulator or something like that down in Houston is that psychologically, you always know that if you're in a simulator, that you're in a piece of equipment that's designed to simulate, and it's not really the thing. So no matter how bad things get, in the back of your mind, you always know that nothing's really going to happen. It just looks bad on the tape, but you can always hit the reset button and put everything back to zero and start all over again. Well, if you're running one of these exosuits, and depending on the type of suit, those pieces of equipment can range anywhere from just over $1 million up to over $10 million, depending on how they're configured and what they're made out of. If you have one of the high-end titanium units that are set up for a 2,000-foot dive, that's a $10 million suit. And not that we were using that particular suit, we were using ones that were just a couple $1,000,000. However, yeah, you swing it around and you bang it into a rock, you break a camera off, or you really damage a limb. These limbs, each segment of the limbs are tens of thousands of dollars. And you scratch or bang one up, and all of a sudden that one's out of certification for doing a real serious depth dive, and so that one has to be replaced. And so if you're the guy that does that, you have real beads of sweat on your brow because you realize that you screwed up. And so that's kind of where that goes. So there's a lot of real pressure that's on these people when they're performing tasks using this equipment, and they realize that it's the real thing. They have real consequences, and if they screwed up bad enough, someone's life could actually be in jeopardy. And so that with those kinds of inherent risks, it adds to that stress level, and it really challenges these people and puts them in a much better position to deal with things real world if they're out on a spaceship traveling from A to B. And that if they encounter something like an oxygen leak in a system, they know that they're going to have to stay up a lot of hours to try to sort that out and isolate where that leak is, and then stop it, because it's not a scenario where you can say, well, I'm kind of tired and I'll start looking into it tomorrow morning or something. It's like, well, everybody on board is all losing oxygen. And so somebody might have to stay up 30 hours to isolate where that leak is and shut it down before everybody else is the unlucky recipients of low O2. So anyway, it prepares them for that kind of thing, and it's a great program in that regard. In the future, where the NEEMO programs are wanting to go, of course, is to continue to bring in new apparatus, new technologies, and test that equipment and prepare themselves for basically using that equipment in real world applications. Something that's kind of interesting, I always try to explain to people when they're asking about some of these programs and how it benefits, you know, everybody else. Well, a lot of materials, a lot of tools and things that are developed eventually find their way into the public marketplace, and especially with materials development and stuff like that, it winds up becoming something that will be used by everybody, and so there's benefits there. The other thing is a kind of an abstract thing that I explained to folks is, let's say you developed a new type of coring bit to get stone samples that you're going to drill or bore in and get these stone samples. You know, when you test this in real world conditions, if you torque that bit a little bit, snap, does it break? Durable enough to last? Can you get by with taking 3 of these bits along with you, because you realize there's no Home Depot, you know, you get to Mars, so everything that you need you're going to have to bring with you. And when you start talking about actual weight combined with everything that you're bringing, food, resources, you know, water, all these things that have to be on board, you know, if I would 3 of these drill bits versus 20, that's a huge difference, because you have to get 20 of these pieces of equipment up to escape velocity from Earth, which requires X amount of fuel, and then you have to transport them from Earth all the way to Mars, which also requires a lot of fuel. And so if you can get by with taking, you know, 2 versus 20, that's a huge difference. And if you sort of extrapolate that out through all the types of things that transport with them, you know, it's beneficial to learn if you can get by with fewer than more. So that's an interesting thing that they can test as well on the way. I think that I'd like to maybe take a look at some of these slides so people can get a look and seeing where this is coming from.
You're assuming that I'm going to be able to do this.
Yeah, well,
I appreciate your confidence.
I do have
Give me a couple clicks here, people. I got to get rid of the meeting controls. So we can see that. Those gray bars will go away in a second. And now I think. All right.
So
off you go, John.
So this is the original poster for down in Florida when we ran the Scott Carpenter Man on the Sea program. And it kind of shows all the different things that were going to be experienced by the participants. So we had the different underwater laboratories. We had a sat, you know, delivery system, so they could lock out of a hyperbaric chamber, lock into a diving bell. The diving bell would deliver them underwater. They would exit the bell, move over to one of the habitats, and then they would start to do their program. Of course, there was submersible there. There was all sorts of basically high-tech commercial type diving apparatus that they had an opportunity to use, you know, communicate, underwater communications equipment, so on and so on. But anyway, this was sort of a depiction. This was the sort of start of, or the seed plant, if you will, of the NASA NEEMO program, was the Scott Carpenter Man of the Sea program. Kind of an interesting sidebar. In 1965, Scott Carpenter, who was one of the nation's first original 7 Mercury astronauts, switched over and started working with the Navy in their Sea Lab missions to basically experiment on human ability to stay for extended periods of time at extreme depths. And so he was moved over already into the Navy Sea Lab program by the time the Gemini space program had started. And in 1965, in August, they did a satellite link up between Scott Carpenter, hundreds of feet down on the seafloor, talking to Gordon Cooper, who was overhead in the Gemini space capsule. So in 1995, in conjunction with the Scott Carpenter program, we did a 30-year anniversary satellite link up with Scott Carpenter in the habitat in Key Largo, speaking with astronaut Michael Gernhardt, who was piloting the Space Shuttle Endeavour overhead. And so we reenacted that program as an anniversary kind of event. It was pretty cool that broadcast live on CNN right from Florida. It was a pretty cool program to be part of. It was neat. So anyway, all right, we can go to the next slide, please. This is a shot of the Aquarius habitat in Marathon, Florida. She sits in about 65 feet of water, and and there's been multiple scientific research projects conducted there over the years, and the NEEMO program is one of those that take place there. And so the astronauts, they learn how to use a lot of high-tech equipment, and we had NUCO research operate down there with one of the NEEMO programs with some of the deep worker submersibles, and so they were able to use those in the program. And off to the right, there's a little PTC station where it's just basically a talking station with a window. Divers can pop in there, take the regulators out of the mouth. They can have a one-on-one conversation right inside an air chamber there without having to go up inside the habitat itself, and then they can go back out and do their work. So anyway, next slide, please. This is another shot of the habitat and one of the portal windows, and you can see a lot of marine growth, of course, is all encrusting around it, and it's becoming part of the environment itself. And it's just kind of an interesting photograph to see how short amount of time it takes for marine organisms to start, reclaiming anything that's down below. All right, next slide, please. Another shot, and you can even see even more growth, and that's also part of the experimentation down there, is to see how long it takes for these organisms to fully engulf a structure down below. And they measure the amount of coral growth and what areas sort of suppress growth and other areas that promote it. And they can measure different areas of the habitat and see which areas are more conducive to promoting organism growth. Anyway, okay, next.
I just want you to know I was tempted to Photoshop my face in there just to see if you would notice, but I did not.
There you go. Okay, this is a Catalina Island. Kind of fun. This is one of the NUCO research dual deep worker subs, and what NASA did was they engineered some airless tires, and then if I remember correctly, I hate to give credit to the wrong group, but I believe Bridgestone got the contract to build them. And they're obviously tires with air in them wouldn't work underwater. The air would be subject to the same hydrostatic weight, and they would end up collapsing. So these are airless tires with basically a series of plastic spokes, and we rigged this sub up so that we could adjust the buoyancy of the sub to mimic less than Earth gravity conditions, and then just operate the thrusters and sort of drive it around on the seabed. And if it hit a small rock or something, the wheel would compress and deform, and then it would spring back to its original shape. But it also would kind of launch the sub up, and it would bounce out, similar to the old footage that you see of the lunar rovers going across the surface of the moon and hitting a bump and kind of bumping up in the air a little bit and then coming down slowly. The subs would mimic that same kind of behavior operationally, and it was fun to do it. So NEEMO project leader Bill Todd and I were actually the guys that got to go out and test these tires for the first time to make sure that they operated correctly and did what we wanted them to do for the astronauts when they got out there. But anyway, that sub was rigged up with these airless tires. It's pretty fun. Next slide, please. That's another look at the same dual worker sub. So the advantage of having a submersible like this is that you can have one dedicated pilot, and then you can have one researcher slash astronaut slash filmer slash whatever, biologist, what have you. So you can have a dedicated pilot and then one other person that doesn't necessarily have to know how to drive the sub around. They both can operate it, but you don't have to have two pilots. You can have one other person that's not fully trained on how to drive the thing around, and then just let the dedicated pilot be the person that's in charge of the craft, and then somebody else can focus on doing something like operating the manipulator or advancing the camera. The cool thing on these is we used laser sighted cameras, so wherever you adjusted the angle of the camera, there was a green laser light that lit up whatever you were or just above what you were wanting to take a photograph of. So if you had, like in this case, if you had a rock that you were interested in, you just could point the laser in that direction, and then the laser sighter would be hitting the rock just above what you were going to take a photograph of, and then you could get that photograph. And so it was a great way to train the astronauts on how to use that type of equipment. And that would be something that they would also use possibly in a real life scenario on Mars or something. All right, next slide, please.
John, just to say, the between the front wheels, I assume that's a collection basket in the front there?
Yes, correct. And there's a manipulator arm, and then the camera and some lights and stuff right there above it. But that manipulator could reach out several feet, and it had a 360-degree rotating wrist, and you could reach out and pick up samples and then bring them back and drop them in the tray. And that was one of the objectives for the astronauts using this craft, is that they had to learn how to use that manipulator, which would be very similar to some of the stuff that they would use in space applications.
Yeah, the Alvin submersible has a similar system on the front with an arm and a basket.
Yeah, and this is just shows how you would get in and out of the sub, and so basically the same kind of thing. So we can skip on to the next one.
It's not a high-tech ladder or some special, $1 million ladder designed specifically to government specifications.
No, it's just a
All right.
ladder. Yeah, thanks. And that's just one of the technicians working on setting the sub up and getting it prepped. But it shows the airless wheels there, pretty good detail of that. And of course, it's got the nice, blue NASA sticker slapped right on the hull there. So that's kind of fun. Okay, next. Next slide. Okay. This is one of the French astronauts, Thomas Pesquet. Super nice guy. And he excelled at piloting subs and the exosuits. He just did really, really well. And we had a couple other U.S. astronauts that did very well as well. So, but yeah, he was kind of a rock star. He went out there and everybody expected good things from him anytime he got in the sub, because he just had a particular knack for it. So, he's one of those guys. He's actually up in the International Space Station as we speak. He's there for several weeks, and he's scheduled to be up there for quite some time beyond. So anyway, he's loving life, I'm sure, right now. He's doing exactly what he trained to do. So anyway, next slide.
John, Andrea had a question on the chat. Where in Catalina did this take place? In other words, did you just dive around the chamber area, the isthmus area, and how deep did the sub operate?
Around Bird Rock and that reef area, around the Fisherman's Cove area by the Wrigley Institute. So, and then some stuff just off the dock area, just right off of their pier. And so just in that general area. But the furthest we did an excursion was out around Bird Rock. And so we were able to get a little bit of depth there, even though the sub is capable of operating at well over 1,000 feet. We weren't operating at those depths. I think the deepest we did any dives there were maybe about 150 feet or so. And that was really not about the depth. It was really about learning how to operate the machines and using some of the capabilities of the machines to go get, collect data. So that was really the focus. So next. And on the far section in the cowboy hat is none other than Bill Todd, and next name is Mark Regan. So those are the two principal guys. Mark is an interesting guy. A lot of you probably seen like movies like Apollo 13 and stuff like that, where you've got these mission control personnel where they're talking to the astronauts. Well, Mark Regan has logged more hours talking to astronauts than anyone else in NASA history. So he's been at the helm of, the Earth base, talking to astronauts more than anybody. And Bill Todd has been sort of involved in NASA. His father was involved in NASA and was really good friends with Scott Carpenter. But Bill was in charge of the space shuttle flight training program for many years, and so he was directly involved with training all the astronauts how to fly the space shuttles. And so when they started shutting down the space shuttle programs, the NEEMO program became something that became his passion and focus. So that's what he leads up now, or heads up now. So anyway, great guys and super assets to our country. Obviously, here's a shot of the deep worker starting to make a dive. And you can see how the side by side, and it's all linked up with comms, and so you can talk and carry on between passenger and pilot and top side. So there's a round robin communication with everybody. Next slide.
I would assume this is the part of the dive where inside they're going, did we really get that seal tight or not?
Yeah, that's exactly that point. That's when it happens right there. Next slide, please.
Coming up. Here we go.
Now here's a great shot. This is one of those rendezvous objectives where we directed the pilot of the exosuit, which is obviously there on the left, and the deep worker sub on the right. And so we said, hey, we need you guys to rally up. And so they would use their Loomis glasses as sort of like a chart plotter, and they would be able to drive to a specific waypoint set up. And we had a bunch of trackers set up in a sort of a triangulated fashion out in the water, and they were pinging to the craft, and then basically run a signal, and then they could sort of create like an underwater GPS, if you will, and let the pilots know where they were in relation to each other, and also in relation to the waypoint where they were supposed to meet up. And then once they rallied, then we'd give them a new objective. So there was, maybe the pilot of the exosuit would have to do an external inspection of the deep worker to make sure that there was no damage, incurred on its mission, or that maybe it would end up stepping up on a step on the back and latching down with the claws on the manipulators on the end of the arms of the suit. You could lock those down, and then it would be able to catch a ride. So it's just a cool shot of those two pieces of equipment working side by side underwater. Next slide, please. And that's a cool perspective. That's a great shot taken from a different angle, and you can see the exosuit is getting ready to latch onto there's basically a handle on the back, and you can use the claws on the ends of the arms, and you can use your hands to lock those down, and then there's a spindle inside the mitt, and you spin that spindle down, and then it locks it in position, and it can't open up. And so if you lock it down on that handle, and then activate the spindle, then it locks down the grip, and then basically it's not coming off. So so then you can hang on, and then the sub can drive, and then the pilot of the exosuit just kind of goes along for a piggyback ride. So next slide, please.
No, I confess I added this next version because as a scuba instructor, the first thing I saw in this was that somebody in the sub said, we can't submerge, we need more weight. And someone said, well, just give me another 10 pounds. And that's what they did. There's the 2 pound. There they are right there.
How close you are to truth, because those craft are set up to a certain a weight configuration depending on who's in there. So it's not a lot unlike going on a normal scuba dive and trying to set up your buoyancy. So ideally we want the craft to get in the water neutrally buoyant, so they neither sink nor float on their own. And so then you operate the thrusters to move yourself around in the water column. And ideally, you don't want them to sink away, because then that means they're going to wind up going off station. If you're trying to be, like say somewhere on a part of a reef and hovering there looking at something, if you're continually having to use the thrusters to hold yourself, in the vertical column, that becomes kind of I guess more of a pain in the ass than anything, because now you're having to use the thrusters to hold you where you want to be, where it should actually be just hovering and neutral buoyancy, and you shouldn't have to do anything but make little sporadic movements with the thrusters to keep you on station, so that you're not getting pushed away by current or something, but not because you're overweighted or underweighted. So anyway, so there's a lot of calculating. You figure out the weight of the pilots, and then you make the adjustments with the, essentially would be your weight belt on the craft, and then you add or subtract weight, and then you achieve your neutral buoyancy, and that's what you're looking for. So
and I looked at it as, here's this multi-million dollar thing, and everyone's going like, yeah, throw 6 pounds of lead on there, that'll fix the problem.
That's exactly right. So anyway, good observation. This was one of my favorite shots. This, and if I remember correctly, I might have taken this one, but this is a great picture. This was, suit being deployed there at the Isthmus. The water looked spectacular at Catalina Island that day, and it's just a fantastic piece of equipment. These, in the real world, are used primarily by oil companies to do work on deep offshore platforms, where they can go down and turn a wrench or take a picture or do an inspection or turn a valve or something like that. And the difference between this suit operating at say 1,000 feet or 1,200 feet or 2,000 feet, depending on the unit that you're using, and a saturation dive, is enormous. The personnel required to run a BELSAT dive at those depths, and the decompression requirements for the divers themselves. I mean, you're talking about, days or potentially over a week in decompression, and all the oxygen requirements and everything that you have to support that operation is reduced down to basically a 4x4 pad and little, like a Connex box for an operation platform for the topside personnel. And so the reduction in footprint on board either a ship or an oil rig platform is enormous, and the ability to go down, do the work, come back up, hop out of the suit, and go have dinner is quite an advantage. Of course, there's certain applications where it's more advantageous to have a sat diver, because they could fit in a narrow quarters or something. But for the right applications, this is an incredible piece of technology. It's really great, and it works well for teaching astronauts how to work with apparatus that's technical and sort of a challenge to operate.
So now imagine those who dove the underwater park, take that to dive the underwater park. Try going down the stairs at low tide in that thing. Not going to happen.
Yeah, they're not a walking suit. That's why all the thrusters and everything's set up on them, and so they are set up with fiber optic, video capability, high tech camera gear with an amazing piece of software on the computer. So the suits that we're using right now, and the job that I'm working on right now, they have basically a 360-degree fisheye lens that the computer software flattens out the image. Instead of having that big balloon kind of fisheye look, it takes all the distortion out on the computer program and flattens out the image, and it's just remarkable. It's pretty incredible, actually. Anyway, but then of course the power reserves to run all the life support and the thruster systems, and then communications are all wrapped up in the single umbilical, so everything's all tied into one. So you got hardwired communications, crystal clear, as good as you and I are talking right now, and the high resolution high definition video capability, as well as the power for life support and thrusters. So it's all incorporated into one big yellow hose. So anyway, that's a cool shot.
Yeah, and it looks like John, that they've got the faceplate is off, the waist is broken in half, and the legs are off as well.
Yeah, well, and that's because it's gone. I'll blow this up. No, that just the boots are off.
Yeah,
So,
that's what I meant. That's what I meant.
Yeah, so the boots are off, and that's a whole other part. Each one of those segments are, like I said, tens of thousands of dollars each component. But so you get in the craft by in the stand, it breaks at the waist. So you get on a ladder, you crawl in the legs, you drop your feet down in the boots, and then you tuck your head up inside, and then we go through a series of checklisting and close the suit down, and then we go through additional checklisting sequences and check the comms and check, make sure the scrubbers are running. Basically, you're living inside of a rebreather, essentially, is what it is. So there's a sort of a formed unit that is the scrubber pack that is almost like a backrest that you can lean back against, and basically as you're metabolizing oxygen and producing CO2, the scrubber is drawing that out of solution, and then you're pumping oxygen back in to make up for what you've utilized. And so actual mission times in these things generally is about 3 or 4 hours max. You could extend that a little bit if you ever doing something that you really had to stay on station for. You could maybe push yourself to stay in there for like 6 or 7 hours, but I mean, you don't have a lot of ability to have a lot of movement. You can move your limbs and everything, but I mean, you're inside. We sort of affectionately refer to it as meat in a can on these suits, and that's an old term. I didn't create it. That's something that Phil Newton kind of coined, over 20 years ago. But basically, meat in a can. You're just in these structures, and you can only take so much. You can get pretty fatigued by being in there for too awful long. Although the life support on these things is required to be able to keep you alive for up to 72 hours. I can't even imagine. But if you were in an entangled situation at 1,000 feet, the 72 hours enables an actual meaningful attempt at a rescue operation. So you could get another craft down there to try to start cutting away lines or whatever, like, to get you out of there. And it'd be hard to manage to pull that off if you only had like a 5 or 6 hour life support system. So that's the reason for the 72 hours. And I'll tell you, I think if anybody was stuck in that thing for 72 hours, they'd probably kill themselves. So
yeah,
it's pretty tough.
And to ask the indelicate question, John, is there a P valve in that thing?
No, there's not a P valve, but if you've got any kind of what we refer to as cameling up, a lot of people will just sort of purposely dehydrate for a while and not take on any fluids for several hours prior. And then you can put on some, adult diapers if you had to, if you thought you were going to be in there and there was any risk of it. So that's pretty common to do that. But there's nothing from the waist down that could be damaged by anything. You just be standing in a puddle, I guess, and that might be uncomfortable, but wouldn't hurt anything. All the sensitive electronics are sort of chest high and up to the head cavity area. So that's where all the life support, adjustment and everything is. All the comm gear and everything like that is all in that upper section. So anything that went downhill wouldn't affect anything really.
One would hope.
Yeah, one would hope. Yeah. This is one of Newco's young and up and coming guy, Jared White. He's just a great kid. I love working with this guy, and super, I love it because being the president of the Historical Diving Society, one of my big principal roles is to try to mentor younger individuals in the diving industry and get them excited about the history of diving. And he's one of those young guys that is just that way. And he's a real treat to work with. He's super, super knowledgeable, has a great work ethic, and he gives you hope for the future, especially in the diving community. He's a great young guy, and I can't speak highly enough about him. So he's a good dude. So next slide, please. Oh, that's a great shot. This is deep worker, dual deep worker and exosuit launching together and getting ready to do the thing. And it's just kind of a fun shot. We can go to the next one. Oh, that's the French astronaut Thomas Pesquat, and of course I'm standing there with him. We're getting ready to launch the suit, and he was doing his pre-dive checks and getting everything ready to go. And it's just a good day, just fun on the island. Next slide, please. This is our NEEMO team for NEEMO Next. This was what was the name of that program, was NEEMO Next. It was the next evolution of it, breaking away from Houston and Florida in the next generation. And I was actually taking this photograph, so I'm not in it. I was taking the photo, but that's our group having dinner one night after. I think this is really close to the conclusion of the whole mission, and we're all kind of in a celebratory mood. So,
and just so you guys know, that's outside the cafeteria, which is above the chamber, if you've ever been over to the island. John, Jim Agronic has a question. As one is moving in the exosuit, what is the position of your body? Straight up and down, leaning forward, or what?
well, just sort of standing vertical. Believe it or not, you have almost like a padded bicycle seat that you're sitting on, and then your legs dangle down into the boots. And ideally, you don't really want to be standing down on the boots. You want to be sort of supported by the bicycle seat, but you want to be able to touch the bottoms of the boots. And the reason for that is the controls for the thrusters are on little pressure pads, little sort of foot pads down in the boots. So if you push forward with your foot or back with your heel, that's going to take you forward and backwards, and you lean left or right on your foot, it's going to turn your right or left. And then on the other boot, you can operate up and down with your pointing your toes down, pushing the pad, or pushing on your heel is going to take you vertically up or down. And so you learn how to operate the suit by a combination of moving your feet. And so you don't want the weight of your body standing on these pads, because then you'd be running the thrusters all the time and not doing what you want to do. So you sort of use your feet as a control to turn the suit and maneuver it as you need. This is our group, our entire NEEMO team down there at the Isthmus, and that was, again, I think this was in the last day or two of the mission, and we're kind of getting into celebratory mode because we'd achieved about 90+% of our objectives for that mission. And the team was really solid. It was a combination of the NASA, the European, the Japanese space agencies, and of course the team from Nuclear Research Limited, which are the manufacturers of the subs that sent their teams down to basically operate them. So anyway, it was a pretty fun group. Next slide, please. Oh, this is a single deep worker. So this is the same kind of sub as the red model, except there's just a single unit. So everything operates the same pretty much, same types of controls, same life support system, et cetera, except it's a single hull for one pilot. Next slide, please. That's Bill Todd, my buddy. I've known Bill all the way back since the Scott Carpenter Man on the Sea days, and trained him to run the first submersible that he ever learned to pilot. And he's actually gone on to learn to pilot the exosuits and the deep workers and other submersible craft as well. And he's quite a guy. He's kind of a legendary character in the NASA circles, but a hell of a guy. So next slide, please. This is kind of fun. This is one of the NEEMO participants. This is European Space Agency astronaut Samantha Cristoforati, who came out to Catalina Island to see me and get some diving in prior to some of her stuff with NEEMO. And she's kind of a character, but she at one time held the record for female for extended duration in the International Space Station, and she's wearing Star Trek uniform, and that's kind of a famous photograph because she snuck in a Star Trek uniform, and then she wore it for that famous photograph. But pretty cool.
And that photo is on the space station for real, right?
That's real. Yeah.
Yeah.
Yeah. Next slide, please.
Yep. Here it comes. There we go.
Now this is funny. So in the Avalon Diving History exhibit in ground floor of the casino building and at Casino Point on the island, she came in to visit, and of all the things that are in there, there is a Roddenberry dive team patch that's up on the wall, and she walked in there and it was almost like it was a magnet. She went directly to that patch and pointed it out because she's a big Star Trek buff. And she went, "Oh wow, cool! Look at this!" I start cracking up. I go, "Of all the things that are in here, that's the thing that you saw first." It blew my mind. So it was just pretty serendipitous. But she's a great person, and I'm kind of happy to call her friend. She's a neat lady. Next slide, please. Okay, this is my buddy who now has been passed away for almost a decade now, but that's Scott Malcolm Carpenter, one of the original 7 Mercury astronauts, and that's when I was training him how to pilot the small one-man sub, the Sea Urchin, and this was the small little mini sub that we used in the MITS program, and then that was, of course, like I said, some of the seed planting of what would eventually become the NEEMO program. But Scott loved that machine. He just had a ball in it. He was always a guy that, well, if you look back on his life, he was originally was a Navy fighter pilot landing his aircraft on the decks of aircraft carriers. And then he got selected as one of the country's original 7 Mercury astronauts. And then he was selected to be in the Navy's Sea Lab programs, where they're living and working with saturation diving technology and living for weeks on end at hundreds of feet of depth. And so he had a pretty full life, but he was absolutely like a kid in a candy shop when he was driving that sub around. And I remember him to this day. He was going through the checklists, and I was talking to him on the headset and going through everything, and he's driving around and he's just going, "This is slick. This is slick." He couldn't get enough of that thing. It was really, really fun. But I would like to conclude my talk here by sharing one of my most favorite Scott Carpenter stories. I was down there on a Sunday morning, probably about 6 a.m., long before many people are up and about in the Florida Keys. And I had my dog, Nico, and I was throwing a toy out there that I had a weighted toy, and my dog was famous for diving as much as 23 feet underwater on a breath hold dive to go to recover his weighted toy. And Scott saw me sitting there, and so he came walking down, surprised to see another early riser, I guess. And he came walking over, and he sat down next to me and patted me on the leg and says, "How's it going, kid?" And I said, "Oh, it's good." I said, "I was sitting there thinking about your career as a fighter pilot, and then a astronaut, and then an aquanaut for the Navy." And I said, I can't believe that you got to do all those things, in your life. Most people, if they had just one of those on their resume, they'd be doing cartwheels. And he says, "Oh God," he says, "don't sell yourself short, kid." He says, "You're driving submarines around, for Christ's sakes." He says, "How bad is it?" And I said, No, I get it, Scott." I said, "I pinch myself all the time. I'm very lucky to be able to pilot submersibles for, part of my life." And I said, "But let's be honest, it's not first astronaut cool." And he kind of acknowledged that. And he says, "Yeah," he says, "those were heady times." And I just thought that's got to be like the understatement of the century. And then he got real quiet and kind of pensive, and he was staring out over Largo Sound, looking across the water. And I thought, oh my God, he's reminiscing. And I was thinking, he's thinking about sitting on top of a rocket, or he's sitting, thinking about sitting in a limousine on a ticker tape parade in New York City after coming home from space, or he's thinking about training for, living underwater, or whatever it was that was in his mind. And he kind of stopped, and he glanced over at me with a little bit of a twinkle in his eye, and he said, they say that you only go around once in life. He says, but do you know what I say? And I was like, oh my God, what? Tell me. Because it's like, whatever it is, it's got to be good. And he kind of glanced around to make sure that nobody else was listening in on the conversation, like they were going to get this gem of information for free. And he looked around, he said, if you move really fast and do a lot of cool shit, it seems like 1.5. And I just busted out laughing. I said, that's absolutely perfect. And that's sort of the message, I think, for all of us, is just keep adding chapters to your story, keep doing things, keep adding to your life, and try to do the best you can to make it seem like it's 1.5. So that's my closing. Thank you.
All right. Thank you much. You see me doing all that, but I was supposed to advance the slide there. That was supposed to, there we go. There it is. All right, let me undo this. And stop that. And welcome back to the land of the living. And thank you, John. That was great. Lots of great stories there. We're happy to entertain any actual questions anyone has, which you can ask verbally, as opposed to writing them in the chat. Andrea doesn't have a question, but she made a statement. Awesome story.
Thank you.
I had a quick question. Was the deep worker, were they tethered or for communications at least, or not?
Yeah, they were. They are tethered for power, and I'm trying to remember. We had a couple different things set up too, because we had some fiber optic stuff that we're piping down for navigation and stuff like that we were trying, that was sort of new, that we're trying to do. But those craft can operate independent without the tether. They can operate that way too.
The exosuit, that's the same type of suit that, didn't Sylvia Earle do like a walk at 2,000 feet or something like that, and something like that?
Yeah, collectively, these types of things. Now, this is, not exactly like new technology as far as in principle. Way back in the 1800s, 1878, the Carmanolo brothers out of France developed a kind of a hand-pounded copper suit that was all designed. And I tell people it's really interesting looking. It's very steampunkish looking. It's got little glass windows, because they couldn't produce one big glass dome. So they had 25 of these little 2-inch windows all over the round dome of the head of this thing. And these enormous joints that were, each joint had a small range of motion, but collectively between all of these segments of the joint, you could get some range of motion. But it was not, so what I tell people, I say it was bold, it was ambitious, it was innovative, and it was a leaker, right? And so your question about Sylvia, she took a craft called a gym suit down to depth, and that she kind of got her title, her deepness, from that. And she was married for a time to a submersible engineer designer, a very famous guy named Graham Hawkes, and they were all part of a kind of a consortium group that did a bunch of design and building of submersible craft for a long time, including her relationship, just professionally with Phil Newton, who was the head of NUCO research. And so it all goes back, quite a few years. But these what are referred to collectively today as atmospheric diving systems are these types of suits or submersibles and things like that. They're a 1 atmosphere craft that enables the pilot to stay at, essentially 1 atmosphere throughout the course of the dive. And then the structure of the hull of the sub or the suit takes up the hydrostatic weight of the water around it, and it is resistant to that weight. And so you are able to remain alive inside this, the meat in a can kind of thing, and and stay at 1 atmosphere for the duration of your dive. And that's what allows the pilots to come out of these craft with no decompression requirements. So they just basically, it's like if you took a mouse and dropped them in a jar and screwed down the lid and took them underwater, he would start to change his environment chemically, but pressure wise, he wouldn't experience any change of pressure. So that's essentially how it works.
Jim, go ahead.
Yes, wonderful story, John. Thanks for sharing. When you took the deep worker to Bird Rock, are you operating off of a barge, and how long is the tether?
Well, that was untethered there. So when we had, it was kind of a combination of how we used it, because some of the times we had a tether because we were using some, we were doing some fiber optic video stuff and things like that we were doing. And then when we were operating over there, we just towed it over there, and then it was free diving on its own.
Okay.
Not the suit though. The suit is always tethered.
Thank you.
You're welcome. Thank you.
Any other questions? Glenn?
Yeah.
I can always count on Glenn for another question.
So what about those Loomis glasses?
Mhm.
They're they sound like fly-by-wire of modern day, but how do they work underwater?
They're just hardwired in, so they're through the fiber optic cable. Well, we ran a separate cable to them, I guess, and then they pipe them in through a through-hole penetrator, and then there's a wire that plugs into basically, if you just picture some glasses on the back of the earlobe section of glass, is basically just a plug insert, and then all that data comes through, and then it has a projection capability from the glasses right onto the lens. It's super high tech. I mean, it was pretty cool stuff to see. And, it just makes you wonder, what the next generation of that kind of stuff will be.
Robin?
2 questions. One is, do they have any kind of temperature control for the aquanaut in the suit? And my second question was, did you ever really get in the suit yourself and get down there and play with it?
Oh, well, for me, no, because I was doing other stuff. I mean, I was helping some people, going in there. So the real work is for the astronauts. So it's not for us. Have I been in this before? Yes. Have I done stuff in them years ago? I've done projects with them, but I've been piloting submersibles for over 30 years. So I've done a lot of submersible operations. I was just talking to some of the guys we're working with today, and off of recollection, I think I've got about 2,300 submersible dives around the world where I was piloting. So I've got a lot of time. I got a lot of stick time. So I'm not like feeling like I'm being ripped off by any stretch if given somebody else an opportunity to get in the machine. And our job is really to monitor the dives, help people, be there. The other question is about the thermal regulation. The answer is no. There's no air conditioning or anything like that. Now, typically, if you're working in a deep water environment, it's pretty cold around you. Yeah. So that sort of offsets everything, because you're in a closed environment. And so even though there's fans running that circulate the cabin atmosphere in order to move basically it moves the air through the scrubber system by force, and it scrubs out the CO2 that you're producing. And it's very efficient in that regard. It can, keep you basically balanced out at essentially 21% oxygen, which is what we're breathing now. It can maintain that for the duration of the dive. There may be a little bit of fluctuation back and forth, depending on if you're doing a lot of manipulation with the arms or something you're actually working stuff. You might be huffing and puffing a little bit and sort of sucking the oxygen down a little bit. And it takes a little while for the scrubber to pull all that CO2 out. So there's a minor, it may drop down to, 19.7 or maybe 20.5%, but it'll stay in that range pretty effectively. But what really happens inside the suits is you're looking to perspire to help cool your body, and there's no place for that perspiration to go to, so they evaporate off, so it gets pretty humid. And so it's almost a blessing to be in colder water because it keeps you at a comfortable temperature. If you're operating in warm waters, it can be almost brutal because you're almost feel like you're sitting in the sauna, so it can be pretty tough. So being down at depth and being in cold water is almost a blessing. So anyway, so that's how that all works. Yeah. And different types of subs, everybody does it differently. So we had different machines that I was telling the guys just the other day that we would take basically commercial grade, like little pint sized, paint thinner type cans, just like a tin can, and we would fill them with water. That thin metal would conduct heat very, very rapidly. And so we'd fill them with, maybe about 78% full of water, and then we screw the lids on it and we'd freeze all the cans. And when the water expanded, there was a little gap at the top that would fill up and wouldn't burst the can. And then you basically had ice cans, and then we had a little plastic tray that sat down underneath the seat of the sub, and then you'd throw 4 of those cans in there, and that would pull all the moisture out of the atmosphere, condense it on the ice in the cans, and would pull the moisture out of the air and drip down in a little sump, and then would keep the cabin kind of cool.
Wow.
That worked pretty well. That was one way to do it. Other subs have heat exchangers where they have a pump system, and it's pumping fluid through a coil that's external, and it's basically water moving through. It's like a radiator on your car. So the fluid is moving through a coil, and the ocean water is pulling the heat out, and then pumping back through, and it just keeps it cycling through. And as it goes through that coil externally, it just draws all the heat off the machine. So anyway.
Thank you.
You're very welcome.
Any other questions? Carl, I notice you have a special Aquanaut there.
It's the cabin.
A Foxonaut.
Yeah.
Yeah.
I got one, Ken.
You look at
All right.
home.
All right, Jeff, go ahead. Carl, we'll get back to you.
Yes, I was wondering how long you're going to be out there at the Isthmus working still.
Are you talking to me?
Yeah.
Yes.
Yeah, I'm not at the Isthmus working now. We did that project. It was originally designed to be a 5-year program, so that we would return for like a 10 or 12-day mission every year for 5 years. But then COVID hit, and you know what happened with that.
Yeah.
So once this all washes over,
Right.
if the funding is there, I'm sure that they would like to return and operate.
Yes, I did hear you say it was canceled because of COVID. I thought maybe someone was still there for a little while working.
No, well, they have all the staff at the Isthmus, but I think even Carl could answer that question better than I. I think that they've been on, at least for a part of the time, was sort of a skeleton crew, and probably had minimal things going on, but still operating, but just at a reduced capacity probably. Carl, you able to respond?
So yeah, we pretty much were shut down for everything for the first few months, except for the chamber crew. We were the only ones here at the lab and maintenance, and actually they kept the kitchen staff busy as well. But the researchers came back during the summer, a lower number of them, probably about 7 or 8 of them over the summer, and then we started gradually looking at pulling classes, and then Delta hit, so we sort of pulled back. But it's gradually opening up, and we'll probably start seeing more activity here come winter semester for USC classes and such. And to answer your question about if they're coming back, I know that our director here has been talking with the people at NASA, so they're still very interested in coming out. They're hoping to get some dates in next year to do same sort of operation.
Great. Thank you.
Cool.
And then one other interesting piece of history. I don't know if you guys are aware that the Aquarius habitat originally was slated to be deployed out here in Big Fisherman Cove back in the 80s. And then when the Hydrolab project or the Hydrolab habitat was retired, it instead went to St. Croix to replace it. So originally they were going to do their, put that habitat out here.
So near, yet so far.
Ken.
Any other questions? All right, well, once again, let's give John a Zoom Seekers round of applause. Thank you, John. That was fascinating on many levels. Remind you guys all the next Zoom Seekers is November, whatever the second Tuesday in November is. Renee Capazola, who is one of our regular Reef Seekers divers and literally started with a point and shoot camera with me one day at the Casino Point and has now literally been named Photographer of the Year, like in a couple of worldwide competitions. So she's going to be our guest next month. She's like in Paris now, judging some photo stuff. So there's hope for all of us. So that'll be next month. So John, again, thank you very much. Thanks for staying up late. And thank you all for joining us for this edition of Zoom Seekers. And we can all wave goodbye, as I always do my favorite thing at the end, which is hit the end meeting for all button. Thanks, guys. We'll see you again soon.
Night.